Hello, this is the fourth video of the Hyperbolic Functions 1 series for OCR Pure Core Further Mathematics, and it looks at differentiating and integrating hyperbolic functions. We can use the definitions below to differentiate cosh x. So that would be the same as differentiating half of e to the x plus e to the minus x, which will equal a half. Differentiating e to the x just gives us e to the x, and then e to the minus x differentiated will be minus e to the minus x. And we could see that this is actually sin x. And you will notice that this is very similar to differentiating the circular trig functions. We have that d by dx of cos x gave us minus sin x. When we differentiate sin x, the result is cosh x, and you can see that this is again similar to d by dx of sin x equaling cos x. Some differentiation of hyperbolic functions may require the use of a chain or the product rule, so watch out for this. Given that integration is the reverse of differentiation, we can therefore also state these results: that the integral of cosh x dx equals sin x plus the constant of integration, and the integral of sin x gives us cosh x plus constant of integration. We may need to use a substitution or integrate by parts, and you may find that the limits, when you're given limits for x, are written in natural log form. In order to differentiate the function f of x equals e to the 2x cosh x, we could either use the product rule or the definition of cosh x. So I'm going to use the product rule here. So I could write it as dy by dx, but I'm going to use f dashed of x. First differentiating the e to the 2x, that gives me 2e to the 2x cosh x, and then differentiating the cosh x to being sin x. I take that factor of e to the 2x out, and then the 2 cosh x would be e to the x plus e to the minus x, and then the sin x is a half e to the x minus e to the minus x. Alright, so I'll take a half out, and that would then give me 3 e to the x plus 1 lot of e to the minus x, which equals e to the x over 2, 3e to the 2x plus 1. Note that the answer you give would depend on what form you're asked to give the answer in. So the working I've done is shown on the left hand side, and on the right hand side you can see this is the working using cosh x at the beginning there. You have to be very careful when you're working with all the exponentials that you use the index laws appropriately. In this question, we'll see that we're asked to find the exact area under the curve shown between x is 0 and x is ln 2. This would look something like this, where this point here is the x equals ln 2 value. So we're integrating between 0 and log 2 the function sinh of 2x with respect to x. And this will give us that standard result, but taking into account the fact you've got 2x, so we have that extra factor of a half, so it's cosh 2x between 0 and the natural log 2, and then using this definition there, we can say that that's going to give us a quarter of e to the 2 log 2 plus e to the minus 2 log 2 minus e to the 0 plus e to the 0. Make sure we put the brackets around that. Which will be, when we calculate it, a quarter of 17 over 4 minus 2, which should give us 9/16. Instead of using that definition of cosh and adapting it to make sure we took into account the fact it was 2x, you could also have used your calculator to get this final answer. So this is this area here. This is the last video of the Hyperbolic Functions 1 series.